Welcome. So I'm pleased to introduce a speaker who's come all the way from Sweden. Thank you, Alice. So she's going to be talking today about automatic systems for making hydroponics, which is going to be awesome. And I want to say that she works with sustainable urban design and also lots of young people in Sweden. And she's based in Stockholm. So if anyone is around Stockholm, check her out. Okay, so take it away. Thank you, Alice.
Thank you so much. Yeah, it's actually sustainable urban development, which is sort of an important point. But yeah, let's do this. This is going to be a really dense, short talk on hydroponics. It's 30 minutes. I will speak really fast, but the slides are available online. And I will absolutely be available for questions. Maybe not here, but at our campsite, and I will give you the address in just a moment. Many of the advances in hydroponics comes from...
wollte auch sagen, wenn man es auf Deutsch hören will, dann wir haben Julian und er übersetzt es heute auf den Decknummer 8012. So 8012, wenn man auf Deutsch hören will. Danke.
Okay. A lot of the advances in hydroponics comes from pot growers, so keep this in mind when I talk about it. I grow vegetables myself, but just so you know. And if there is any problems with my presentation graphically, it's not only on me, because Keynote hate human beings, so you have to excuse me for that. Okay. Why I want to work with hydroponics is because it is a really important part of sustainable development, partly because hydroponics uses about 1% of the water used in conventional growing. It does not have any need for sunlight, which makes it possible to grow it indoors in completely controlled environments. It also is not using any of the non-renewable resource soil, which I think will have to be looked upon as a non-renewable resource, since it takes about 500 years to renew a 2 centimeter thick layer of growable soil. I also think it's important to help people to be able to grow food, to get an idea of how growing food works. And hydroponic systems are simple to set up, even if you're living in a small space and have a limited amount of money also. So I will give you a short hydro history, hopefully very short, and the slides will be really quick. But as I said, the slides are available online and you can look it up afterwards. I will talk a lot about how plants grow in hydroponics, as well as normally it's the same thing basically. What measurements you need to know about if you want to build automated systems, what do you need to measure and what values and so on. And I will also show you pictures of some of the more common systems and tell you a little bit how they work. There you see the link for the slides, and there is also, did I put the link in? Yeah, there is also some resource document with links and some additional info. And you can find me in the camp afterwards, T10 on the map, if you want to ask questions or be with us when we build a little on-site system. So, okay, what we're talking about is growing in a manner that does not use soil. We can use a lot of other manners of sort of medias to grow in, but no soil. That means you have no nutrients in the medium, but you add all nutrients, and in most of the case it's in the water. That's why it's called working water or hydroponics in Greek. It's mostly referred to as soilless growing, so that you know. So hydroponics is not at all a new field. It's been around for a really long time. We can begin at, 600 BC, Babylon. The Hanging Gardens of Babylon, probably hydroponic, we don't know for sure. Possibly that they had some mechanical automations, but we don't know. There are indications. The Aztecs was 1100 AC. They used something called the chinampas, which is like floating islands, using the roots hanging down into the lake. Very hydroponic, but more like run like traditional agriculture. So a little bit later in time, 1627, we have Francis Bacon and Sylva Sylvanum. This is, as far as we know, the first printed mention of growing directly in water or in nutrient solution. 1699, a guy called John Woodward grows spearmint, and he can prove that plants grow better in contaminated water than in distilled water. So this is like the beginning of nutrient solution growing. 1860s, we have Sachs and Knopp, two botanists, and they developed the first nutrient solution recipe, basically, and they had no focus on automation whatsoever, as far as I know. 1929, Jericke is probably the most important guy in soilless gardening history. He got really discredited and ended his career in a bad way, but he's the guy. He doesn't get enough credit. Read his book, fantastic, but it's old. So, 1930s, Pan American Airlines wanted to fly from America to China. They needed to stop on the way. Wake Island became one of those stops to be able to give food to the personnel on the planes and first and foremost the passengers. They started growing hydroponically because Wake Island has no soil and no fresh water. So, automated, probably how much, I don't know. I have to read up on Wake Island project. So 1938, these two guys, what are they again? Let me see. Just a moment. Oh, this is not right. Oh, okay. Hoagland, he is known for the Hoagland solution, and him and his colleague were the ones that sort of was the reason why Jericke got discredited. Jericke didn't want to release his recipe as open source in the university because he was denied greenhouse time, so it ended up with the university assigning to Hoagland and Arnon, his colleague, to reshape the recipe, and they did, and they got all the credit. No focus on automations with these guys. In the 1960s, you can imagine what kind of growing culture was sort of interested in hydroponics by now. There is a guy called Alan Cooper, and he develops a technique called the nutrient film technique, and it's still one of the most popular techniques for hydroponics. I will show you how it sort of system looks like a little later. He was interested in automations. He used control of pumps and control of lights, as far as I know. I haven't read his publications fully. In 1982, the Disney World Eptok Center opened something called the Land Pavilion, where they have a future of horticulture part, and they have some hydroponics there, and they do a lot of development in automation of systems as well. For how long NASA has been doing the controlled environment support, life support systems, we don't know, probably for some time. Lately has been discussed, partly because they were eating hydroponic salad on the ISS, and it was a few days ago, if I got it correctly. And what they're trying to do is basically grow food where it's not possible to grow food, space station, and also colonization like Mars. And if we are lucky, I think by 10 tonight, we can watch the ISS having dinner, and if we're lucky, they're having hydroponics for dinner. We will see. 2009, a revolutionary thing happens. Britta Riley, a New York-based, I think she's an art student from the beginning. She releases a research and develop it yourself community called windowfarms.org. This is sort of at the beginning of a lot of home builders in hydroponics. The community is still active. This is the version 3.0. She released the community with her version 1.0. It's a really large community. It's a fantastic amount of solutions and people to talk to. It's a good place to start if you want to build your own system and look at automated systems in the future. There are not that many solutions in the community that solves the whole automation process like nutrients, water, pH, EC, and I will go into them later. But there are many that solves pieces of it. So it can be a really nice resource if you want to find facts on how to do it. And last but not least, in the aftermath of the tsunami earthquake thing in Japan, a guy called Shimamura took an old semiconductor factory and turned it into the world's largest indoor farm. And they grow only salad, and they produce about 10,000 heads of lettuce every day. And they are looking at a complete automated process, including looking for nutrient deficiencies in the plants by optical readings of the colors of the leaves. So they are like absolute front line of automated systems. I don't think they're open source though. But so this is the factory from the inside, I guess. Yeah. So we will quickly go over to how plants grow in hydroponics, and it does not differ from how plants grow generally. It's the exact same thing, but some parts are more important than in a regular system. It does not matter if it is, I was showing you the Mirai factory of salad, or if it is a tomato on your balcony. Some things are basically exactly the same. All plants need light, all plants need nutrients, and all plants need water, including oxygen. And if you provide these three, plants will grow. Plants love to grow. They always want to grow. So even if you're sloppy, they will probably grow, but you won't get an optimized yield or so on. But I usually say when I help people to come to the decision to build their own system that it's hard to optimize, but it's even harder to completely fail. So you should just start doing it and then develop slowly. We will start at the roots. The roots is in any hydroponic system extremely important. The roots is, even more important in a way than if you are growing in soil, because you can pay it more attention. So it becomes a bigger part of your involvement in your system. Most plants, with a few exceptions, their roots be sort of, how do you say it? They're divided into three parts. Where the lowest part drinks water, it does not like air. Actually, if it's exposed to air for too long time, it will suffocate. The middle part is, how do you say, a hybrid, and it can drink both water and air to get oxygen. And the top part is like you and me, it drowns in if you put it through in a water or too moist environment for too long time. But all parts of the roots need darkness. This is what you have to work with when you don't use soil to cover the roots. You have to cover the roots in some other way because they need darkness. Otherwise, they burn. And you also need to how do you say, oxygen saturate your water, because all parts of the roots need oxygen as well as the leaves, because all parts of a plant exchange gases, CO2 for oxygen, oxygen for CO2 all the time. So this is super, super important. So more about the water. It's nothing strange about it, except that it's the absolute most important part in a hydroponic system. It provides the drinking water for the plants, as in any other manner of growing. All plants have different needs, more water, more often, less often. You have to take a look at what plants you want to grow before you start building your system, and especially before you start building automated systems, so that you know what measurements you have to work with. Always keep your water saturated. You can do it by building a stream, like a dripper system, but you can also do it by an air stone, like the thing you have in an aquarium, that you push the air into the stone and it gets divided into really small bubbles, and you will have you will have a good oxygen saturation, so to speak. I can see now that I have very little time left, but I think maybe I was interrupted, so maybe I get a few minutes more. Water level, you have to measure water level. It's super, super crucial. No shortages. There are many ways to measure it. The most simple way, I guess, it's an electrical circuit. You can build simply at home. There are really expensive professional tools for professional price that continuously measures the water levels. Depends on what you want to do. The water is also a nutrient agent, and we have to measure pH to be able to know if the plants can assimilate the nutrients, because at the wrong pH level, the plants cannot assimilate the nutrients. The nutrients are available as ions in the water in inorganic form of salts. And for the, how should I will post a link to a really nice table that will show you how the different nutrients get locked out at different levels of pH. I guess you know what pH is and how it works. You don't want to go below 5 and you don't want to go above 7. Most plants dwell between 5.8 and 6.5. So if you keep it there, you can, maybe you're not optimizing, but you won't fail, basically. To measure pH, you use a meter or a sensor. If you want to build your own system, preferably you will use a sensor, and you will get a relative pH, it's relative to temperature, and this is a problem generally when you measure some things. There are really expensive measure tools that compensate for temperature, but as before said, to a professional price. You can also correct the pH by using chemicals, pH up, pH down kind of chemicals. You can also flush your system. If you're looking at building an automated system that automatically corrects the pH, I know of one or two projects who is semi-successful. The links are in the resource text file online, so I won't say anything more about it, but yeah. So EC, electrical conductivity, is super important when you work with hydroponics. This is the presence of ions in the water, and you can say a lot about it, but you can measure it in EC, you can measure it with, what's it called, the TDS, I think it's an American way, they measure it in ppms, and EC measures it in Siemens, millisiemens or microsiemens. There are sensors, you can use meters, they're basically the same, but the difference between the TDS and in parts per million or EC, I don't have time to explain here, but there are good links in the text file. Over to the nutrients. This is, of course, really important. This is what you add to the water. The water is supposed to be no nutrients in the water to begin with. That's why you measure EC in the water before you add the nutrients and during your growing period. So which are the nutrients? We have the micronutrients, nitrogen, phosphorus, and potassium. We have the secondary micro and the micronutrients. They are super important, all of them, but they are divided like this because of the sort of the amount that they are needed in the solution. Nitrogen stimulates growth of biomass. It's really important at the beginning of a growth period of a plant. It's said to be the most important nutrient, but strictly speaking, they're all equally important. With a total deficiency of one nutrient, it won't work at all. So, yeah. Phosphorus for fruit set and energy. Plants need to bind energy in chemical bindings, so from sun or from any other light source or heat source. And phosphorus is really important in this process. And the potassium, this also stimulates fruit set, the bud set, but it's also really important for plants to build resistance to a lot of diseases. This is actually something that we don't know exactly how it works, but a really important thing. I think I will have to jump some here. This is something on the light. As far as we know, you don't need any natural light. You can grow on completely artificial light when you grow food or whatever you're growing. What you need to remember also, recent research has shown that you can treat your plants with 24-hour, 24/7 light, and it doesn't seem to be a disadvantage, but this is at an early stage of research. What you need to remember is what color temperature your light has. You also need to remember to check the heat radiation from your lights and the strength of the light. The heat radiation is an issue, even with LEDs, because of the amount of LEDs that you will use in a small area to produce the light that you need, so keep it in mind. There's some tips on artificial light, and it's the redder spectra is for flower and fruit. stimulates flower set and fruit set, and the bluer part is for biomass growth. So this is a good sort of pointer to have. Temp and humidity, also really important to measure. You don't want temperature above 12. I've had problems with this in Sweden this summer. I notice you haven't had that problem here. Most plants won't set fruit under 12 degrees. Temperature, humidity, which is also very so dependent on temperature, you want to go between 30 and 70%, and you measure this with sensors, and there are sensors available for all these measurements. I don't have as much time to go into them as I would like, but yeah, we can have questions at the camp later. If you build a greenhouse for your plants or a sort of closed environment, you really, really have to look out for the heat and the humidity and what they do to each other. It's extremely important that you have an airflow, because both the leaves and the roots need to have oxygen to be able to exchange gases. So make sure that you have some airflow in your system, whatever you do. Oxygen, yeah. So what you have to think of, sort of what you should sort of take with you from here is like, where do you place it? What do you want to grow? What do you want to measure? And how automated do you want your system to be? I will go really fast through a couple of systems. This is the NFT, the nutrient film technique. It's really popular. It's fantastic for home growing. It's small but serious growing. It's perfect for small but serious. It's easy to set up. It's kind of cheap. It takes a little space. It's simple to exchange the water without displacing your plants, which is a really good thing. It's very popular, but it has 2 pumps, makes it a bit noisier. If the pumps fail, your plants will die extremely quick, so it's sort of susceptible to problems. And the roots can clog the systems, so make sure to always check the roots. Ebb and flow, I will show you 2 pictures, up and down pump. It's easily maintained, same reason as NFT. Simple to flash, you can control basically anything around the nutrients very precisely, and also the water. As with any closed system, there is a problem with disease control, since all plants share the same water, and the water isn't flowing, but standing more still and just going up and down. So, aeroponics are really popular amongst pot growers and industrial-sized growing. It's very efficient. It's like making the absolute most of your hydroponics. It's more expensive to set up, and it's difficult to maintain. If the mist nozzles get clogged, you will have instant problems. Also, it's susceptible to some specific diseases because of the high moisture level in the air. I think salmonella is a problem, so yeah. Pros and cons. Fish, aquaponics, I mean, it's a lovely idea, but maybe if you want to farm your own vegetables, you don't want to have an aquarium or a fish farm as well, so it's like another thing, but it's popular and it's being developed in several big universities around the world, so it could be fun to try. The deep water culture, this is one of my absolute favorite. I have one at home. I will build one in our camp later tonight or maybe tomorrow. It takes like 1 or 2 hours to build yourself. It's really, really cheap, easy to take care of. This is absolutely something that I would like to recommend you to try as a first thing. And we have the dripper system, which was made really famous by Britta Riley and the Window Farm project. It's very simple. It's not the most efficient. It's kind of silent, and most of all, it's super, super cheap to set up, and also kind of easy to maintain when it comes to automation. The problem is that the water flow is difficult to see how much water is actually being taken up by the plants. Oh shit, the time. I have mentioned growing media. Here is some examples of what you can use. Basically anything that doesn't hold too much nutrients from the beginning. This is a list of parts you can use if you want to build your first dripper system. All this information is online, and you can come and talk to me at the camp, and I will tell you everything I know. The current status on automation, I will not go into this because there is one project, a Billybricks hydroponic controller built with Arduino. It's a fantastic source of information. You should absolutely look it up. There are other projects. Some of them have copied his project basically just as its whole and just rewritten the descriptions. So I really recommend you to, if you want to start working with automated hydroponic system, first of all, look at the Billybricks project and see what is possible, because it's done a really, really good job. And the code is available, the discussion is really thrive. A lot of people continuously work or is involved in the discussion, and it's lively. So you should really take a look at it. Since I sort of stressed a little, I have a few minutes left. If you have any questions or want me to go back to an older slide, it's possible. He was asking about the fish thing. It's called aquaponics, and I can give you a short explanation. The fish, you give the fish food, the fish poop in the water is pumped up to the plants. The plant make use of the nutrients, and they also clean the water, and the water goes back to the fish in a state where they can keep pooping in it.
I saw something very interesting. So people make something called earth ships. So they take the water they use for showering, and then this water gets to moisture the plants, and the people also get the moisture of the plants because they have half size of the house as a greenhouse, and so they get the moisture and the warmth of the greenhouse, and so they can heat their dwellings, and also they can close the windows they have in between, so they can say it's enough warm and enough moist. I want to have some other air, but I'm interested to make a whole system. So you have your fish, you have your plants, and you don't have to pay utility bills and things like that, and you'll be self-sufficient.
Yeah, that would be fantastic. That would be.
It's one thing that if I'm away, that the system still flushes the toilet, because otherwise the flowers will die.
Yeah, but that's grand projects is fantastic. Come over to my camp and talk to me later.
Where are you?
I will show you. I will go back to the slide.
Okay.
Is there another question as well?
I'd like to take it over to the other side in the green, please. Please go ahead.
Hello. I wanted to ask, how much more efficiency, if any, does an automatic system gives to an hydroponic system?
It depends so much on where you're putting your effort in. I don't have any numbers on how efficient it's possible to make it. Quite some, I guess. What you don't have when you automate, or if you make an automation that actually works, is that you can have continuous availability of nutrients for the plants. You have no water shortage. You can prolong the time of light exposure to your plants. I also have some interesting things about measuring light with power values. You will have to discuss this later, but I don't have a number for the efficiency. I mean, we already have more and half, how do you say, like more than you can have half the size where you grow your crops in hydroponics and get more yield than you would in 100% area of traditionally grown. So already there you have a huge advantage in yield, but the efficiency depends on how you want it to work. You want to go away 5 weeks or 1 week, or but the continuously attending to plants is the key why hydroponics is so efficient.
One last question. We've got time for one last.
You mentioned that different plants have different requirements for the nutrients and so on. Is there something like a public catalog where I can look this up for different species and strains?
I haven't found a collected catalog with this, but there is huge amount of info online. Unfortunately, as I said, a lot of it is directed at pot growing, but there are also other sources of information. But it's a good place to start, because they are really serious people when it comes to growing. So start there. But there are, of course, I mean, when it comes to all these measurements, of course, there is info. Of course.
Thank you very much for your talk.
Can you all please put your hands together? Thank you, Alice Blukin.